Hello grade 12s and welcome to part 1 of 3 videos in which we will learn the nomenclature rules for organic compounds. These are the rules that we use in order to name different organic compounds that belong to different homologous series. I split this up into 3 videos because I've included a lot of examples that we're going to go through together to make sense of the rules. There are 12 rules that I have listed in total. Let's look at rule number 1. It says identify the functional group of the molecule to determine the ending or suffix of its name. There are 9 different homologous series and therefore 9 different functional groups that we study this year. We start off with the alkanes. These are hydrocarbons that only contain single bonds between their carbon atoms, and their names end in ane. The alkenes contain a double bond. They're also hydrocarbons, but they have a double bond between at least one pair of carbons in their chain, and their name ends in ene. The alkynes are hydrocarbons that contain a triple bond between a pair of carbon atoms, and their name ends with ine. The haloalkanes have their name end with ane, just like the alkanes, but they are not alkanes and belong to a completely different homologous series because in their structure we have halogen atoms like fluorine, chlorine, bromine, and iodine. The alcohols contain the hydroxyl group and therefore their name ends in -ol. The aldehydes always have their functional group on the first carbon in their chain. This functional group is known as the formyl group, and the name of the aldehydes ends with -anal. The ketones have a functional group that looks similar to that of the aldehydes, except that this double bond O exists on a carbon atom that is between at least 2 other carbon atoms. The name of the functional group of the ketones is the carbonyl group, and the name of the ketones ends with -one. We then have the carboxylic acids. The carboxylic acids have as their functional group the carboxyl group. Their names end in anoic acid, and the carboxyl group on the carboxylic acids always falls on the first carbon in their chain. Lastly, we have the esters. The esters functional group looks similar to that of the carboxylic acids, but you're going to find this functional group in the middle of the chain or somewhere in between carbons, and the name of the esters ends with -08. Rule number 2 says that when we write out the names of different organic substances or molecules, we leave no spaces between words, or in other words, no spaces between letters. Number 3 says that numbers are separated from words with a hyphen. Rule number 4 says numbers are separated from numbers with a comma. And number 5 says that the number of carbon atoms in the longest continuous chain determines the stem names of organic compounds. These stem names are given in the pink block displayed to your screen. For 1 carbon, we use the stem name or root name meth. 2 is eth, 3 prop, 4 bute, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, and 10 dec. You need to know these names off by heart. So let's look at example number 1. We start off by identifying the functional group of this compound, and we find out that this is in fact an alkane. So its name ends with ane. Now we need to determine the longest continuous chain. It looks like the longest continuous chain is this one. But if you look very carefully, you're going to notice that what we think is the first carbon has another carbon attached to it at the top. And what we may think is the last carbon is not the last carbon because it has a carbon atom connected to it at the bottom. The longest continuous chain here therefore contains 5 carbon atoms, and therefore we're going to use the word pent, making the name of this compound pentane. We can now move on to rule number 6, which says, the following prefixes are used for alkyl groups and halogen atoms. Another word that we use for alkyl groups is the word branches. And in general, we can refer to the alkyl groups and halogen atoms as substituents. So there are many new names, many new words that you're going to have to learn to be comfortable with this section of organic chemistry, but I'm 100% certain that with practice you'll be able to master each of the terms. The alkyl groups or branches are given different names based on how many carbon atoms they contain in their chains. When there's only one carbon atom, we use the name methyl. When there are two carbon atoms, we use the name ethyl. The halogen atoms are given the following names. For fluorine, we use the word fluoro. Chlorine is chloro, bromine is bromo, and iodine is iodo. We're now going to use the rules that we've just learned to name these examples, example number 2 and example number 3. We always begin by identifying the functional group of the compound, and in example number 2 we can clearly see that there are only carbon and hydrogen atoms with only single bonds between the carbon atoms. So this molecule is therefore an alkane and its name ends with ane. We now need to identify the longest continuous chain, and it looks as though this is the longest continuous chain, with this and this being branches or alkyl groups. But if you look very carefully, you will notice that what we think is the first carbon is connected to this carbon as well, and the one at the end is connected to this one. So what is now highlighted is in fact the longest continuous chain. When we count the number of carbon atoms in the longest continuous chain, we find that it contains 8 carbon atoms. So we use the word oct as the root name for this compound. Now we notice that in between we have a methyl group. We must not only name this methyl group, but state on which carbon it falls. So in order to do so, we need to number the carbons in the chain. If we number from the right, then we have carbon 1, 2, 3, 4, 5, 6, 7, and 8 like this. And this means that the methyl group falls on carbon number 5. But if we instead number from the left-hand side, then we have carbon 1, 2, 3, 4, 5, 6, 7, and 8. And you can clearly see that now the methyl group falls on carbon number 4. We would like to name these compounds so that the substituents have the lowest number possible, and therefore we're going to use the numbering system from the left. The methyl therefore falls on carbon number 4. We call this 4. We use a hyphen to separate the numbers from the words, and it is therefore 4-methyl octane. That is the name of this compound. On to number 3. In number 3, we start off by looking for the functional group, and over here we can see the functional group, a double bond OOH that falls onto the first carbon. This compound is therefore a carboxylic acid with a carbonyl group as its functional group. The names of the carboxylic acids end in anoic acid. This is one of 2 cases where there will be a separation between words, between the main part of the word and of the name and the word acid. So you're allowed to leave this gap in between. Now we need to identify the longest continuous chain, but the longest continuous chain must contain the functional group. So therefore the longest continuous chain will be this one over here. If we count the number of carbons in this longest continuous chain, we find that there are 6 carbon atoms. And therefore, we're going to use the word hex to refer to these 6 carbon atoms. When we number the carbon atoms, we must start numbering from the carboxyl group, the functional group. So we have carbon 1, 2, 3, 4, 5, and 6. There is a branch or substituent over here. This branch contains 2 carbon atoms and is therefore called an ethyl group. We need to go and include the position and the name of this ethyl group in the name. So we therefore say 3-ethyl hexanoic acid. And that is the name of example number 3.